There are nights when the universe opens its eyes. Picture yourself standing in the high desert, where the air is thin and the darkness stretches endlessly above. No city lights to soften the cosmic theatre. Just you, the cold, and 10 billion points of light scattered across the celestial dome like seeds thrown by an ancient hand. Most of these lights have been there since humans first looked up, steady, predictable, following their eternal dance through seasons and centuries. But sometimes, something new appears. On a particular night in early 2019, automated telescopes scanning the southern sky caught something that shouldn't have been there. A wanderer, a visitor from the deep spaces between stars, following a trajectory that traced its origin to somewhere impossibly distant. The Discovery networks flagged it immediately. Another interstellar object, only the third confirmed visitor from beyond our solar system's boundaries. They named it 3I Atlas, but 3I Atlas was different from its predecessors. When Oumuamua tumbled through our neighbourhood in 2017, it reflected sunlight like any ordinary rock, growing brighter as it approached our star, then fading predictably as it departed. When Borisov arrived in 2019, it behaved like the comet it was, developing a tail, outgassing, following the ancient script written by countless icy wanderers before it. 3I Atlas refused to follow any script at all. From the moment telescopes locked onto its path, something felt, or perhaps something felt intentional. While other interstellar visitors had been dim, difficult to track, requiring the most sensitive instruments to study, 3I Atlas announced itself with an unmistakable glow. Not the reflected brilliance of sunlight catching ice or rock, but something else entirely. Something that seemed to emanate from within. Astronomers compared it to a lighthouse beacon crossing the cosmic dark. As it travelled through the outer reaches of our solar system, still far beyond the orbit of Jupiter, it maintained a steady, inexplicable luminosity that defied every model of how interstellar objects should behave. Spectroscopic analysis showed wavelengths that didn't match any known mineral composition or gas emission. The light wasn't coming from solar heating, wasn't the result of sublimating ice, wasn't the glow of cosmic radiation interacting with surface materials. 3I Atlas was simply bright, as if it carried its own star within. For months, observatories around the world tracked its approach. Unlike the frantic scramble to study Oumuamua before it disappeared forever, 3I Atlas gave astronomers time. It moved with unhurried purpose along its hyperbolic path, neither accelerating unexpectedly nor deviating from its trajectory. It seemed patient, almost deliberate in its visibility, as if it wanted to be seen. Night after night, the observations continued. Professional telescopes and amateur stargazers alike turned their attention to this glowing visitor. Social media filled with images, long exposure photographs showing a brilliant point of light moving against the background stars, leaving a trail like a cosmic breadcrumb leading back to the infinite dark from which it came. But there was something unsettling about those images, something that made observers pause and wonder. In an age where we've mapped the genetics of distant galaxies and measured the spin of black holes billions of light years away, 3I Atlas resisted understanding. Its glow remained constant, unaffected by distance from our sun, uninfluenced by the solar wind or magnetic fields it passed through. It simply shone, as if powered by principles we hadn't discovered yet. Some observers reported an odd sensation when viewing it through their telescopes, a feeling of being watched in return. Of course, this was dismissed as psychological projection, the human tendency to assign consciousness to patterns in the stars. But the reports kept coming, whispered among amateur astronomy circles and mentioned quietly in professional forums. There was something about 3I Atlas that felt aware. The object's trajectory suggested it had been travelling for millions of years, perhaps tens of millions, crossing the gulfs between stars at speeds that made its journey an epic of cosmic endurance. Where had it come from? What distant sun had once warmed its surface before it was flung into the eternal night? And why, after so long in the cold and dark, did it arrive in our system burning with its own mysterious fire? As autumn deepened into winter, 3I Atlas continued its steady approach toward the inner solar system. Predictions showed it would reach its closest point to our sun sometime in early spring, then begin the long journey outward, eventually escaping our gravity well and returning to interstellar space. Astronomers prepared for intensive study during its closest approach, hoping to finally understand the source of its enigmatic glow. The brightness remained constant night after night, steady, reliable, like a promise being kept or a signal being maintained for an audience that might finally be paying attention. But promises, as we would learn, can be broken. Signals can choose silence, and lights that burn with such determined brilliance sometimes do so only until they've captured exactly the attention they were seeking. Do you think some cosmic visitors might choose when to be seen and when to disappear? Share your thoughts below as we continue this journey into the mystery that would soon deepen beyond all expectation. Because 3i Atlas, after months of faithful luminosity, was about to teach us something profound about the nature of cosmic intentions. It was about to show us that in a universe full of predictable physics and mathematical certainties, some phenomena reserve the right to simply stop. And when that moment came, when the light that had travelled so far and burned so steadily suddenly chose darkness, astronomers around the world would be left staring into their telescopes, confronting a question that would haunt them. Why would something so luminous choose to disappear? There are moments in science when instruments capture something that shouldn't exist, a reading so impossible that the first instinct is to check for malfunction. But what happens when dozens of instruments scattered across continents and operated by different teams all register the same impossible thing at exactly the same moment? The first report came from the Palomar Observatory at 3:47 a.m. Pacific Time on February 14th, a routine monitoring session, part of the ongoing campaign to track our mysterious visitors' approach toward the inner solar system. The astronomer on duty, reviewing the night's photometric data, noticed something that made her pause and run the analysis again. The brightness reading showed a dramatic drop, not the gradual dimming expected from a tumbling object changing its orientation, but a sharp, sudden decrease that defied explanation. Within hours, similar reports began flooding astronomical networks worldwide. The European Southern Observatory in Chile confirmed the dimming. Radio telescopes in Australia registered a corresponding drop in thermal emissions. Even amateur astronomers with modest equipment noticed that the brilliant point of light they'd been tracking for months had become significantly fainter overnight. But it wasn't just the magnitude of the change that troubled observers, it was the synchronicity. Across time zones and continents, telescopes had witnessed the same phenomenon at the same moment. When accounting for light travel time, the dimming had begun simultaneously across the object's entire visible surface. This wasn't a natural process like outgassing or surface erosion, which would create gradual, uneven changes. This was something else entirely. The data streams told a story that challenged everything astronomers thought they knew about interstellar objects. For months, brightness measurements had shown remarkable stability, variations of less than 1% from night to night, the kind of consistency that suggested either a perfectly spherical shape or a completely uniform surface composition. Then, within a span of 6 hours, the luminosity dropped by nearly 40%. More disturbing still was the pattern of the decline. Rather than a smooth curve showing gradual dimming, the light curve showed discrete steps, periods of stable brightness punctuated by sudden drops, as if someone were systematically turning down a series of switches. Each plateau lasted approximately 90 minutes before the next reduction occurred. The mathematical precision of these intervals felt deliberate, purposeful, almost controlled. Radio astronomers pointed their dishes toward the fading visitor, hoping to detect some electromagnetic signature that might explain the dramatic change. What they found was silence. Not the chaotic static of natural radio emissions from a heating object, but an absence so complete it seemed almost manufactured. It was as if the object had not only dimmed its visible light, but had gone quiet across the entire electromagnetic spectrum. Observatories scrambled to capture as much data as possible before the visitor disappeared entirely. Teams worked around the clock, coordinating observations across multiple wavelengths, sharing data in real time through secure networks. The astronomical community had witnessed many cosmic phenomena: supernovas, gamma-ray bursts, the collision of neutron stars. But this felt different. Those events, however spectacular, followed the known laws of physics. This dimming suggested something operating by rules we hadn't discovered yet. As the days passed, the brightness continued its stepwise decline. Each 90-minute interval brought another reduction, each drop precisely measured and documented. The object was still visible, but barely, requiring increasingly sensitive equipment to detect against the background stars. Amateur astronomers who had easily photographed it just weeks earlier found their telescopes insufficient to capture even a trace of its former brilliance. The dimming wasn't random or chaotic. It followed a pattern so precise that some observers began referring to it as a countdown, though to what nobody could say. The mathematical regularity suggested intention, as if the object were following a predetermined sequence, executing a plan that had been set in motion long before it entered our solar system. Theories emerged and were quickly discarded. Could the visitor be tumbling in such a way that reflective surfaces were being systematically hidden? The timing was too precise. Could it be passing through a dust cloud that was obscuring its light? No corresponding material was detected. Could it be fragmenting, with pieces breaking away and taking their luminosity with them? Telescopes showed no debris field, no expanding cloud of particles. The most unsettling possibility was the one that scientists hesitated to voice publicly, that the dimming was intentional, that something was actively controlling the brightness, methodically reducing its visibility according to some internal logic or external command. The idea challenged fundamental assumptions about the nature of interstellar objects, but the data refused to support any conventional explanation. As the second week of dimming progressed, a strange phenomenon began occurring in observatory control rooms around the world. Astronomers reported an uncanny feeling while watching the real-time data feeds, a sense that they were witnessing not a natural process but a performance. The precision of the timing, the deliberate nature of the steps, the complete absence of random variation, all contributed to an impression that something was choosing to fade from view. Some described it as watching a lighthouse in the distance systematically reduce its beam strength, cutting power to lamp after lamp in a predetermined sequence. Others compared it to observing a spacecraft powering down its systems one by one, entering some kind of hibernation mode. The analogies were unsettling because they implied consciousness, decision-making, purposeful action, qualities that rocks and ice weren't supposed to possess. The media picked up the story, though most coverage focused on the scientific mystery rather than the more speculative implications. Headlines spoke of fading visitor and dimming asteroid, treating it as an interesting but ultimately explainable phenomenon. Behind closed doors, however, astronomers were grappling with data that suggested their visitor might be something far more complex than anyone had initially assumed. By the end of February, the object that had blazed across the sky like a cosmic beacon had dimmed to less than 10% of its original brightness. Ground-based telescopes could barely detect it. Only the most sensitive space-based instruments could track its continued journey toward the inner solar system. The brilliant visitor that had announced itself so dramatically was quietly slipping away into darkness. But even as it faded, it left behind something that would prove even more haunting than its original luminosity: the memory of precision. The undeniable evidence that its dimming had followed rules, patterns, sequences that suggested far more than random physics at work. Whatever was happening to our visitor, it was happening by design. And in the quiet hours of observatory shifts around the world, as astronomers stared at screens showing the faintest trace of what had once been brilliant, a disturbing question began to form. If something could choose to dim itself with such methodical precision, what else might it choose to do? The answer, as we would soon discover, lay not in what it might choose to do, but in what it had already chosen to stop doing, and why even our most sophisticated theories couldn't explain the elegant mathematics of its disappearance. In the face of cosmic mysteries, science reaches first for the familiar. When confronted with the impossible, our minds seek refuge in the known, searching for natural processes that might explain what we're witnessing. But what happens when every reasonable explanation crumbles under scrutiny, leaving us standing at the edge of our understanding, staring into a void that stares back with mathematical precision? The first theory seemed almost too obvious to consider. Perhaps our visitor was simply tumbling through space in such a way that its reflective surfaces were being systematically hidden from view. Asteroids and comets rotate as they travel, presenting different faces to observers over time. A highly reflective surface turning away from Earth could certainly explain a dimming effect. Astronomers modelled this scenario with painstaking detail. They calculated rotation periods, mapped potential surface compositions, and ran thousands of simulations showing how a tumbling object might appear to fade from our perspective. The mathematics were elegant, the physics well understood. It should have been the answer everyone was hoping for, but the data refused to cooperate. The precise 90-minute intervals between brightness drops were far too regular for chaotic tumbling. Real asteroids don't rotate with stopwatch precision. They wobble, they precess. They exhibit the subtle irregularities that come from being genuine chunks of rock shaped by millions of years of cosmic collisions. Our visitor's dimming pattern was too clean, too mathematical, too deliberately structured to result from natural rotation. Moreover, spectroscopic analysis during the dimming phases showed something troubling. The wavelength distribution of the fading light remained constant. If reflective surfaces were simply turning away, observers should have detected changes in the spectrum as different materials became visible or hidden. Instead, the light maintained its mysterious spectral signature even as it dimmed, as if the source itself were being systematically reduced rather than obscured. The second explanation focused on dust. Perhaps our visitor was passing through a cloud of interplanetary particles that were gradually blocking its light. Spaces filled with microscopic debris, remnants of ancient collisions and stellar wind, and such material could theoretically create a dimming effect as it accumulated between the object and Earth. This theory gained initial support when astronomers calculated that even a relatively sparse dust cloud could cause significant dimming over time. The mathematics worked beautifully, predicting gradual light reduction as particles accumulated along the line of sight. Several research teams published preliminary papers suggesting this was the most likely explanation for the mysterious fading. But once again, the precision of the dimming pattern posed insurmountable problems. Dust clouds don't create stepwise reductions in brightness. They cause gradual, smooth dimming curves as particles slowly accumulate. The sharp drops and stable plateaus observed in our visitor's light curve were incompatible with any known dust distribution model. Additionally, infrared telescopes failed to detect the thermal signature that should accompany dust heating in sunlight. If particles were blocking the light, they should have been glowing faintly in infrared wavelengths. The absence of this signature effectively eliminated dust as an explanation. The third natural explanation involved distance effects and observational geometry. Perhaps the visitor's trajectory was carrying it behind some unseen obstacle, a dark asteroid, a concentration of space debris, or even gravitational lensing effects that could systematically reduce its apparent brightness from Earth's perspective. Orbital mechanics specialists traced the object's path with exquisite precision, mapping its trajectory against known objects in the solar system. They accounted for every significant gravitational influence, every piece of catalogued debris, every potential obstruction along the line of sight. The calculations were thorough, the modelling sophisticated, the attention to detail exemplary. Yet no obstacles existed along the visitor's path. Its trajectory carried it through regions of space that were remarkably clear of debris, far from any known asteroids or cometary nuclei that might cause periodic obscuration. The geometry was all wrong for lensing effects, and no undiscovered objects of sufficient size could account for the observed dimming without having been detected by other means. Perhaps most frustrating was the failure of fragmentation models to explain the phenomenon. When comets approach the Sun, they often break apart under thermal stress, with pieces separating and carrying away portions of the original brightness. This process is well documented, thoroughly understood, and seemed like a promising explanation for our visitor's fading luminosity. Astronomers eagerly searched for debris fields, hoping to spot the telltale signs of fragmentation, expanding clouds of particles, multiple point sources where there had been one, the chaotic light curves typical of objects breaking apart. They deployed the most sensitive instruments available, coordinated observations across multiple wavelengths, and processed data with algorithms designed to detect even the faintest traces of fragmentation. The searches revealed nothing: no debris field, no secondary objects, no expanding particle clouds. The visitor remained structurally intact even as it dimmed, maintaining its point source appearance while systematically reducing its luminosity. If it was breaking apart, it was doing so in a way that defied every known model of cometary fragmentation. By early March, the astronomical community found itself in an uncomfortable position. Every natural explanation had been tested, modelled, and found wanting. The precision of the dimming pattern, the mathematical regularity of the timing, the absence of expected signatures for known physical processes, all pointed towards something operating by principles that hadn't been catalogued in textbooks. Some researchers began exploring more exotic possibilities. Could the visitor be composed of materials with unusual optical properties, substances that change their reflectivity in response to solar radiation or magnetic field variations? Could it be exhibiting some form of sublimation so uniform and controlled that it appeared artificial? Could unknown physical processes be at work, phenomena that Earth-based science had never encountered? These speculations led to increasingly complex models involving exotic matter states, unknown chemical reactions, and theoretical physics at the edges of current understanding. Each proposal required assumptions about materials or processes that had never been observed, mathematical frameworks that stretched the boundaries of established science. The more exotic the explanations became, the more they highlighted a disturbing reality. Science was running out of natural answers. The visitor's behaviour was so precisely controlled, so mathematically elegant, that it seemed to demand explanations involving intention, purpose, design. But acknowledging such possibilities meant stepping beyond the comfortable realm of natural philosophy into territory that made many researchers deeply uncomfortable. In laboratories and conference rooms around the world, scientists found themselves confronting a possibility they had trained themselves never to consider seriously: that some phenomena in the universe might not be governed by random physical processes. That intelligence, consciousness, purposeful action might sometimes masquerade as natural objects, travelling between the stars with agendas we could barely comprehend. The failure of natural explanations wasn't just an academic problem. It was an existential challenge to humanity's understanding of its place in the cosmos. If our visitor was dimming according to some internal logic, if its behaviour suggested control and intention, then we were no longer alone in the universe. We were being observed, studied, perhaps even tested by something that had travelled vast distances to reach us. As March deepened and the visitor continued its methodical fade into darkness, astronomers faced a choice between clinging to increasingly implausible natural explanations or acknowledging that they might be witnessing something that transcended the boundaries of known physics. The evidence was becoming impossible to ignore. Natural bodies simply don't behave with such mathematical precision. They don't dim in perfect increments, maintain spectral consistency during brightness changes, or execute patterns so regular they resemble countdown sequences. But if our visitor wasn't following natural laws, then what laws was it following? And who or what had programmed them into its luminous heart before it began its journey through the cosmic dark? There comes a moment in every mystery when the impossible becomes the only explanation left standing. When every reasonable theory has been examined and discarded, when the evidence points toward conclusions that challenge our deepest assumptions about reality, we face a choice: retreat into comfortable denial, or step forward into the unknown territory where new possibilities wait to be discovered. What if our cosmic visitor had never been a natural object at all? The thought occurred simultaneously to researchers around the world as they stared at data that refused to conform to any known physical process. If the dimming pattern was too precise for natural phenomena, if the timing was too regular for random physics, if the spectral consistency was too perfect for ordinary matter, then perhaps they were witnessing something engineered rather than evolved, designed rather than naturally formed. Consider the original luminosity that had first captured our attention. For months, the visitor had maintained a steady brightness that defied every model of how interstellar objects should behave. Natural bodies don't carry their own light sources through the cosmic void. They reflect what illumination they encounter, growing brighter as they approach stars and dimming as they retreat into darkness. But our visitor had glowed with consistent intensity while still far beyond the reach of significant solar heating. What if that glow had been artificial from the beginning? What if the light wasn't reflected or thermally generated, but produced by some form of technology we couldn't yet comprehend? Propulsion systems, perhaps. Exotic engines that converted matter to energy with such efficiency that they appeared as steady illumination across vast distances, or communication arrays, broadcasting signals into the void with luminous beacons that announced their presence to any civilization sophisticated enough to notice. The possibility reframed everything we thought we knew about the visitor's journey. Instead of a dead rock tumbling through space for millions of years, we might have been observing an active system, a piece of technology maintaining itself during an interstellar voyage of incomprehensible duration. The steady brightness wasn't an anomaly, it was evidence of operational status, proof that whatever mechanisms drove the visitor remained functional after eons in the cold and dark. Human spacecraft provide instructive parallels. Our deepest space missions carry power sources designed to function for decades, systems that can enter hibernation modes to conserve energy, communication arrays that can be selectively activated or shut down depending on mission requirements. We've built satellites that go silent for years before reactivating, probes that power down non-essential systems to extend their operational lifespans. What if our visitor had been doing something similar on a vastly larger scale? What if the dimming represented not malfunction or natural decay, but a deliberate transition into some form of standby mode? The mathematical precision of the process suggested systematic shutdown procedures, perhaps powering down different systems in sequence to conserve energy for critical functions. The 90-minute intervals between brightness reductions took on new significance through this lens. Rather than arbitrary timing, they might represent the operational periods of different subsystems, propulsion units cycling down, communication arrays reducing their output, navigation systems switching to minimal power mode. Each step in the dimming sequence could correspond to specific technological components entering dormancy. This interpretation explained the spectral consistency that had puzzled astronomers. If the light source was artificial, then reducing its output wouldn't necessarily change its wavelength distribution. Unlike reflected sunlight, which varies in spectrum as different surface materials become visible, artificial illumination could maintain consistent characteristics even while dimming. A technological light source powering down would simply become less bright while preserving its original spectral signature. The complete radio silence that accompanied the optical dimming also supported technological explanations. Natural objects don't suddenly stop emitting radio waves. Thermal radiation continues as long as temperature differentials exist, and cosmic ray interactions generate electromagnetic signatures regardless of optical brightness. But a technological system could choose to go radio quiet, shutting down transmitters and communication arrays as part of a comprehensive stealth protocol. Perhaps most intriguingly, the timing of the dimming suggested awareness of observation. The process had begun shortly after our most intensive study campaigns were announced, almost as if the visitor had detected our attention and responded by reducing its visibility. Many technological scenarios could explain such behavior. Automatic stealth responses triggered by external observation, programmed protocols for avoiding detection by primitive civilizations, or even active decision-making by whatever intelligence guided the visitor's journey. The idea of purposeful concealment raised profound questions about the visitor's intentions. Why would something travel so far, announce its presence so dramatically, then choose to hide just as we were beginning to understand its significance? The behavior suggested testing, perhaps evaluating our technological capabilities, our observational skills, our level of interest in interstellar phenomena. Alternatively, the dimming might represent a form of cosmic courtesy. Advanced civilizations might have protocols for minimizing their impact on developing worlds, procedures for reducing their visibility once they've completed whatever observations or measurements brought them to our solar system. The systematic nature of the dimming could reflect sophisticated planning, a gradual withdrawal designed to avoid causing disruption or panic among Earth's population. Some researchers speculated that the visitor might be part of a larger network, one node in an interstellar communication or transportation system that had completed its local mission and was preparing to depart or go dormant. The precise timing could represent coordination with other elements of such a network, shutdown procedures synchronized across vast distances to maintain operational security or conserve resources. The energy requirements for such sustained artificial illumination were staggering by human standards, but not necessarily impossible for sufficiently advanced technology. Fusion processes could theoretically provide stable power for millions of years. More exotic possibilities: controlled matter, antimatter reactions, quantum field manipulations, or energy extraction methods beyond current understanding could explain virtually unlimited power generation in compact systems. What emerged from these speculations was a picture of our visitor as something far more sophisticated than initially assumed. Rather than a passive object shaped by random cosmic forces, it might represent active technology, an artifact of intelligence that had crossed interstellar space with specific purposes in mind. The dimming wasn't decay or malfunction. It was evidence of sophisticated operational procedures, proof of technology so advanced that its routine functions appeared mysterious to our more primitive understanding. The psychological impact of this possibility was as significant as its scientific implications. Humanity had always wondered whether we were alone in the universe, whether intelligence existed beyond Earth, whether other civilizations had mastered interstellar travel. Our visitor's behavior suggested that these questions might have been answered, not through deliberate contact or dramatic revelation, but through subtle observation of a technology so advanced that we had initially mistaken it for a natural object. If the visitor was artificial, then its journey to our solar system wasn't random. Something had sent it here, programmed it with specific instructions, designed it to operate independently across the vast distances between stars. The implications were humbling and exhilarating in equal measure. We were not alone, but we were also being evaluated by intelligences whose capabilities exceeded our own by unimaginable margins. As the visitor continued its methodical fade into darkness, astronomers found themselves grappling with the possibility that they had witnessed humanity's first confirmed encounter with extraterrestrial technology. Not the dramatic arrival depicted in science fiction, but something subtler and perhaps more profound. Evidence that the universe was filled with active intelligence, that other minds had gazed across the cosmic void and chosen to explore what lay beyond their homeworlds. But if our luminous visitor was indeed a technological artifact, if its dimming represented a conscious choice to withdraw from observation, then what did its brief appearance in our skies mean? And what might its silence teach us about the nature of intelligence that spans the stars? Human memory runs deeper than written history. In the stories our ancestors carved into stone and whispered around fires, in the myths that survived countless retellings across millennia, there may be traces of truths we've forgotten how to recognize. What if the strange behavior of our cosmic visitor wasn't unprecedented at all, but part of a pattern that has repeated itself throughout human history? A cycle of appearance and disappearance that our ancestors witnessed and tried desperately to record for future generations. Ancient Chinese astronomers kept meticulous records of celestial phenomena, documenting what they called guest stars, sudden appearances of bright objects in the night sky that blazed for weeks or months before vanishing completely. These events were considered omens of great significance, harbingers of dynastic changes or cosmic disturbances that would reshape the world below. One account from the Han Dynasty describes a visitor that appeared in the constellation we now call Aquarius, burning with the brightness of Venus at dawn for nearly 3 months before beginning a systematic dimming that the court astronomers described as the retreat of the celestial messenger. The object didn't fade gradually like a dying star, but reduced its luminosity in what the records describe as 7 deliberate steps, each lasting the span of a full moon cycle before the next reduction occurred. The mathematical precision recorded in these ancient texts is startling. 7 steps, each lasting approximately 30 days, creating a dimming sequence that spanned 7 months from peak brightness to complete invisibility. The Chinese astronomers noted that the spectral quality of the light remained unchanged throughout the dimming process, describing it as maintaining the pure white fire of heaven, even as it faded from view. Half a world away, Mayan codices tell of Itzamna's torch, a wandering star that appeared during the reign of a great king and blazed across the sky with unusual consistency. According to the astronomical records preserved at Palenque, this visitor maintained steady brightness for 4 seasons of plenty, before beginning what the scribes called the counting down to silence. The Mayan description of this countdown is remarkably detailed. The visitor's light reduced in exactly 13 steps, with each reduction occurring at intervals the astronomers measured as 70 days. Like their Chinese counterparts thousands of miles and centuries away, the Mayan observers noted that the star maintained its essential character even while dimming, describing how the voice of Itzamna grew quiet but never changed its song. 13 steps of 60 days each, a total dimming period of over 2 years, during which the visitor methodically reduced its brightness, according to a pattern so precise that the Mayan astronomers incorporated it into their ceremonial calendar. The mathematical regularity was seen as proof of divine intention, evidence that the gods themselves were counting down to some cosmic event of profound significance. In the archives of medieval European monasteries, scattered references appear to similar phenomena. Irish monks on the island of Skellig Michael recorded the appearance of the Wandering Light of St. Michael in the year 847 CE, an object that blazed above the Atlantic horizon with unchanging brightness throughout the winter months before beginning what their chronicles describe as the Great Dimming. The monastic records describe this dimming as occurring in 9 sacred intervals, each lasting from new moon to new moon, suggesting a pattern of monthly reductions that spanned nearly a year. The monks interpreted the event as a divine sign, but their astronomical observations were remarkably precise. They noted that the light maintained its pure silver radiance throughout the dimming process, never changing in colour or quality even as it grew fainter. Perhaps most intriguingly, biblical scholars have identified references that may describe similar phenomena. The Star of Bethlehem, traditionally interpreted as a supernatural sign, is described in some apocryphal texts with details that suggest a more complex sequence of appearance and disappearance. References to the star completing its mission and returning to the silence from whence it came hint at purposeful behaviour rather than random celestial mechanics. Even more suggestive are passages in the Book of Enoch that describe watchers, luminous beings that appear in the heavens, observe the earth for appointed periods, then withdraw according to predetermined patterns. These watchers are described as maintaining their brightness according to the count of their purpose, before dimming step by step as befits their wisdom. Indigenous Australian Dreamtime stories speak of the counting star, a visitor that appears during times of great change, burns with steady fire while listening to the songs of the people, then withdraws its light bead by bead until it returns to the dreaming. The dimming process is described as taking place over multiple seasons, with the star reducing its brightness at intervals synchronized with tribal ceremonies. What emerges from these scattered accounts across cultures and centuries is a disturbing pattern. Time and again, human civilizations have witnessed luminous visitors that behave with mathematical precision, appearing suddenly, maintaining consistent brightness for extended periods, then dimming according to regular predictable patterns before vanishing entirely. The consistency of these reports across disparate cultures suggests something more than mythological invention. Ancient observers had no means of communicating across continents, no shared scientific framework for understanding celestial phenomena. Yet their descriptions show remarkable similarities. Sudden appearance, sustained brightness, systematic dimming in discrete steps, preservation of spectral characteristics throughout the fading process. Modern astronomers might dismiss these accounts as primitive attempts to explain natural phenomena like supernovas or comets, but the mathematical precision described in these ancient records doesn't match the behaviour of known stellar events. Supernovas fade chaotically over years or decades. Comets dim gradually as they retreat from the sun. No natural astronomical phenomenon creates the stepped, regular dimming patterns described in these historical accounts. What if our ancestors were witnessing the same type of visitor that we observed in our modern skies? What if the precise mathematical dimming of our recent cosmic guest was part of a recurring pattern that has played out throughout human history? A cycle of visitation and withdrawal that advanced intelligences have been conducting for millennia. The implications are both humbling and profound. If these ancient accounts describe real events rather than mythological inventions, then Earth has been under observation far longer than we might have imagined. The systematic nature of the dimming pattern suggests that whatever intelligences operate these visitors have been following consistent protocols across centuries, perhaps millennia. The timing of these historical appearances is also suggestive. Many occur during periods of significant human development, the rise of new civilizations, the development of written language, the construction of great monuments. The Chinese guest star appeared during the Han Dynasty's golden age. The Mayan torch burned during their classical period of astronomical achievement. The medieval European sighting coincided with the Carolingian Renaissance. Perhaps these visitors represent some form of long-term monitoring program, with different objects arriving at intervals to observe and assess human progress. The systematic dimming could be part of a departure protocol, a way of gracefully withdrawing once observations are complete, while leaving minimal disruption to the observed civilization. The mathematical precision of the dimming patterns also suggests coordination between different visitors across time. The specific number of steps, the regular intervals, the consistent spectral preservation, these details hint at standardized procedures, protocols developed by intelligences that think on timescales that dwarf human history. If our recent visitor was indeed following ancient patterns, if its methodical dimming echoed behaviors recorded in myths and legends across human cultures, then what does this tell us about the true nature of our cosmic neighbourhood? And how long we have been part of a larger story whose scope we're only beginning to glimpse? In the language of the cosmos, sometimes the most profound statements are made through absence rather than presence. What if the careful, methodical dimming of our visitor wasn't an ending at all, but the message itself? What if everything we witnessed, the sudden appearance, the months of steady brilliance, the mathematically precise fade into darkness, was a carefully orchestrated communication designed to convey something that could never be expressed through conventional signals? Consider how intelligence reveals itself in our own world. The most sophisticated communications often lie not in what is said, but in what is deliberately withheld. A conductor's raised hand creates more powerful music through silence than through sound. A master painter understands that empty space defines the subject as much as pigment and line. Perhaps advanced civilizations have learned similar lessons about cosmic communication, that true intelligence is demonstrated not by constant broadcasting, but by the controlled deployment and withdrawal of signals. Our visitor's behavior, viewed through this lens, becomes a masterclass in interstellar messaging. The initial appearance was the opening statement, a declaration that something artificial, something controlled had entered our neighbourhood. The months of steady luminosity served as confirmation, proof that this wasn't a random, natural phenomenon, but something maintaining itself deliberately, purposefully, with technological precision that defied our understanding of physics. But the dimming, the careful, stepped reduction in brightness, this was where the real communication began. Each 90-minute interval wasn't arbitrary timing, but part of a complex mathematical signature. The pattern itself was the message, a demonstration of control so precise, so obviously artificial, that it could only be interpreted as intentional communication by any civilization sophisticated enough to recognize mathematical sequences. The number 90 minutes holds particular significance when viewed from Earth's perspective. It represents approximately one orbit period for objects at certain altitudes around our planet, a timing that any spacefaring civilization would immediately recognize as meaningful. By choosing this interval, our visitor may have been demonstrating awareness of our orbital mechanics, showing that it understood our local gravitational environment with intimate precision. The systematic nature of the dimming suggested something even more profound, a test of our observational capabilities and intellectual curiosity. Would we notice the pattern? Would we recognize the mathematical precision? Would we understand that such regular behavior couldn't possibly be natural? The visitor seemed to be calibrating its message to our level of technological development, providing just enough anomalous behavior to capture our attention, while avoiding anything so dramatic as to cause widespread panic or disruption. This interpretation transforms the entire sequence of events into an exercise in cosmic diplomacy. The visitor had announced itself gradually, allowing our scientific community time to observe and analyze its properties. It had maintained consistent behavior long enough for us to establish baseline measurements and recognize its unusual characteristics. Then, once it was certain we were paying attention, it began the slow, deliberate demonstration of controlled dimming that could only be interpreted as artificial intelligence. The message embedded in this sequence was both simple and profound. We are here. We are aware of you. We can control our visibility at will. But perhaps most importantly, we choose when and how to reveal ourselves, and we choose when to withdraw. This last element was crucial. It established that any contact or communication with our species would occur entirely on their terms, according to their protocols and timeline. The absence of radio signals during the dimming process reinforced this interpretation. A natural object continuing to fade would maintain thermal emissions, cosmic ray interactions, and other electromagnetic signatures. By going completely quiet across all wavelengths, the visitor demonstrated total control over its electromagnetic output. This wasn't passive fading, it was active stealth, a deliberate choice to become undetectable. Perhaps most intriguingly, the timing of the dimming's initiation coincided with increased attention from Earth's astronomical community. The visitor had begun its systematic fade shortly after major observatories announced coordinated observation campaigns, almost as if it had detected our heightened interest and responded by beginning its withdrawal protocol. This suggested not just technological sophistication, but real-time awareness of our activities. The message became clear. We know when you're watching. This level of awareness implied monitoring capabilities that extended far beyond passive observation. The visitor seemed capable of detecting changes in our observational intensity, recognizing when it had become the focus of systematic study rather than casual notice. Such sensitivity suggested a level of technological sophistication that was almost incomprehensible by our current standards. The mathematical precision of the dimming pattern also served as a signature, a way of establishing authenticity for future reference. Any civilization capable of recognizing the artificial nature of the pattern would also be able to reproduce it, to verify its mathematical properties, to confirm that they had indeed witnessed something beyond natural explanation. The pattern itself became a cosmic watermark, proof that genuine contact had occurred. But why communicate through disappearance rather than continued presence? The answer might lie in the psychology of observation itself. Constant visibility would eventually become mundane, integrated into our normal expectations of reality. By withdrawing, the visitor ensured that its brief appearance would remain memorable, significant, worthy of continued study and contemplation. Absence creates longing. Disappearance demands remembrance. The strategy also demonstrated remarkable restraint and wisdom. Rather than making dramatic gestures that might cause social disruption or panic, the visitor had chosen a subtle approach that would be recognized by scientists and astronomers while remaining largely invisible to the general population. This suggested an understanding of our social dynamics, an appreciation for the potential consequences of overly dramatic contact. The dimming pattern might also serve as a form of cosmic diplomacy, establishing protocols for future interactions. By demonstrating controlled withdrawal, the visitor showed respect for our autonomy, proving that it wouldn't force contact or remain present without invitation. This approach suggested civilizations that had learned to approach other species with careful consideration for their development level and social stability. From this perspective, our visitor's behavior represented the cosmic equivalent of a polite introduction, arriving with enough fanfare to be noticed by those equipped to understand, demonstrating its artificial nature through mathematical precision, then gracefully withdrawing to allow us time to process the implications. The ball, as it were, was now in our court. The message hidden in disappearance also carried philosophical implications about the nature of cosmic communication. Advanced civilizations might have learned that the most profound truths can't be transmitted through data dumps or direct instruction, but must be discovered through careful observation and contemplation. By providing just enough information to establish its artificial nature, then withdrawing, the visitor forced us to think deeply about what we had witnessed. This approach honoured our intellectual independence while providing unmistakable evidence of contact. We weren't given answers. We were given a puzzle that could only be solved through careful, scientific analysis and logical deduction. The process of understanding became as important as the understanding itself. If our visitor's disappearance was indeed the message it came to deliver, if the careful mathematics of its fading were designed to demonstrate controlled intelligence rather than natural decay, then what does this tell us about the patience and wisdom of civilizations that measure their communications in cosmic time? And what might they expect from us in return? In the deepest nights, when the sky's clearest and the stars shine with ancient light, we find ourselves searching the darkness for signs of what we've lost. The absence of our cosmic visitor has left more than just an empty patch of sky. It has opened a space in our understanding that can never quite be filled by conventional explanations. But perhaps that emptiness itself is the gift, the invitation to imagine possibilities that stretch far beyond the comfortable boundaries of everything we thought we knew about our place in the universe. The search continues, though it has taken on qualities that feel more like vigil than science. Radio telescopes sweep the heavens nightly, their vast dishes tilted toward the coordinates where our visitor last appeared, listening for any whisper of electromagnetic activity that might betray its presence. Infrared surveys scan the outer reaches of the solar system, hoping to catch the faintest thermal signature of something moving through the cold spaces beyond Neptune's orbit. Advanced space-based observatories, equipped with sensors more sensitive than anything available during the visitor's initial appearance, maintain automated watch patterns designed to detect even the slightest resumption of artificial illumination. The search protocols have become almost liturgical in their precision, systematic, patient, conducted with the reverence usually reserved for sacred rituals. Yet the silence persists, not the chaotic quiet of empty space, but something that feels more deliberate, more purposeful. The absence has weight to it, presence through non-presence, as if our visitor has chosen a form of visibility that exists only in memory and anticipation. But cosmic patience operates on timescales that dwarf human experience. What feels like abandonment to us might represent the briefest pause in a conversation that spans millennia. Advanced civilizations that think in geological time might consider our visitor's withdrawal as merely the space between sentences, the moment of silence that gives meaning to what comes before and after. Consider the possibility that the visitor's journey didn't end with its disappearance from our telescopes, something capable of controlled interstellar travel, of maintaining artificial luminosity for months while crossing vast distances, of executing mathematically precise dimming sequences. Such technology doesn't simply vanish into nothingness. It continues, perhaps following trajectories that carry it to other star systems, other worlds, other civilizations that might benefit from similar demonstrations of cosmic awareness. The pattern of appearance, observation, and withdrawal might be part of a much larger program, a systematic survey of intelligent life that has been underway for millions of years. Our brief encounter could represent just one data point in an unimaginably vast catalogue of contacted civilizations, each visited according to their level of development, each given the same careful demonstration of artificial intelligence before the visitors move on to the next coordinates on their endless journey. From this perspective, the dimming wasn't an ending but a transition, the completion of one phase in a cosmic protocol that we're only beginning to understand. The visitor had accomplished what it came to do: establish contact with our scientific community, demonstrate its artificial nature, test our observational capabilities, then withdraw to allow us time to process the implications. Mission completed, it continued on to other destinations, other species that might be ready for similar revelations. But the mathematics of orbital mechanics suggest intriguing possibilities for return. If our visitor followed a hyperbolic trajectory out of the solar system, if it maintained some form of propulsion capability, then its journey might not be linear. Advanced technology could enable course corrections, trajectory modifications, even complete reversals that would bring it back to our neighbourhood according to schedules we can't yet predict. Perhaps the visitor operates on cycles measured in decades or centuries, returning periodically to check on the progress of civilizations it has contacted. The historical patterns identified in ancient records suggest such periodicities, regular appearances separated by spans that exceed human lifespans, but remain consistent across cultural memory. If so, then our recent encounter might be just the latest iteration in a cycle that has been repeating throughout human history. The thought is both humbling and exhilarating. Somewhere in the darkness between stars, our luminous visitor might be maintaining its patient course, following navigation protocols that will eventually curve its trajectory back toward the inner solar system. The timing of such return visits could be calibrated to our rate of technological development, designed to occur when we've had sufficient time to absorb the implications of the previous encounter. What would we see if it returned today? Our observational capabilities have advanced significantly, even in the months since the dimming occurred. New telescopes, more sensitive instruments, better data processing algorithms. all focused on the possibility that the visitor might choose to resume its luminous journey. The next appearance would be observed with unprecedented precision, analysed with tools that didn't exist during the first encounter. But perhaps the question isn't when the light might return, but whether we'll recognise it when it does. Advanced technology capable of controlled visibility might also be capable of selective revelation, appearing only to observers who have demonstrated appropriate levels of understanding or preparation. The next manifestation could be even more subtle than the first, detectable only by those who learn to recognise the mathematical signatures of artificial intelligence. The visitor might also return in forms we haven't anticipated. The original appearance as a luminous object crossing space represented just one possible manifestation of advanced technology. Future encounters might involve different phenomena, radio signals with mathematical content, gravitational wave signatures that encode information, or even more exotic possibilities that exist at the edges of theoretical physics. What remains constant is the sense that our brief encounter changed something fundamental about humanity's relationship with the cosmos. The visitor's appearance forced us to confront the possibility that we are not alone, that intelligence spans the galaxy, that other minds have gazed across the same stellar distances and chosen to explore what lies beyond their origins. The dimming showed us that such intelligences operate by principles of patient observation and respectful withdrawal, approaching other civilizations with wisdom accumulated across unimaginable spans of time. In observatories around the world, the search continues with quiet determination. Not the frantic urgency that might be expected from humanity's first, potential contact with extraterrestrial intelligence, but something more thoughtful, more reverent. The understanding has grown that if our visitor was indeed artificial, if its behaviour demonstrated genuine cosmic intelligence, then the timeline for any future contact will be determined by consciousness that thinks in cosmic rather than human time. The waiting has become part of the message itself. By teaching us patience, by forcing us to contemplate the vast scales on which true cosmic intelligence operates, our visitor began our education in the realities of interstellar communication. The silence isn't empty, it's pregnant with possibilities, heavy with the potential for revelation that could come at any moment or might not occur for generations. In the meantime, we've learned to watch the skies with different eyes. Every anomalous reading, every unexpected signal, every faint object moving against the stellar background carries new significance. The visitor's brief appearance has sensitized us to the possibility that the universe is far more active, far more aware than we ever dared imagine. And in the quiet hours before dawn, when the telescope operators change shifts and the automated systems continue their patient surveys, there persists a sense of expectation. Not the anxious anticipation of those who demand immediate answers, but the deeper patience of those who have learned that some truths reveal themselves only to minds prepared to wait as long as necessary. The cosmos operates on its own timeline, follows protocols developed across billions of years of stellar evolution and planetary development. Our visitor's brief appearance may have been just the opening note in a symphony that will unfold across centuries, a conversation that began with controlled dimming and might continue through forms of communication we haven't yet learned to recognize. For now, we watch and wait, knowing that a star that chooses to vanish is not gone but merely patient, not absent, but temporarily displaced, existing in the spaces between our observation and our understanding, between our questions and the answers that travel toward us at the speed of light, carrying messages written in the language of controlled brilliance and deliberate darkness, reminding us that in the vast conversation of cosmic intelligence, some lights appear only when we have learned to see, and some voices speak only when we have developed the wisdom to listen to the profound teachings hidden in the patient mathematics of disappearance and return.